Hey everyone, it's Mr. Canfield. Today in Algebra 1 we are doing 7-4 factoring polynomials using a GCF. Okay, that's a mouthful. So we should talk about what factoring is. Let's talk about factoring by using numbers, okay? So let's say we have 3 times 5. What is that? That's 15. So 15 is what you get when you do 3 times 5. So if we said factor 15, then we would say, oh, 15 factors into 3 times 5. We're taking it and we're breaking it down into its factors, into things that multiply together to equal it. Wow. So one thing to mention about factors is that 1 is a factor of everything, right? I could say this is 1 times 3 times 5, but we don't say that. We don't say that because since 1 is included with everything, we don't need to mention it for anything. So we could also say, what are the factors of 15? And the different factors of 15 are 3 and 5. But here we could say, well, 1 is also a factor of 15. So, okay, so just in case that word wasn't clear to you, that's what that word means, factoring. So when we're looking at a polynomial, like let's say we're looking at 8x squared plus 12. The way that we factor polynomials is we reverse the multiplication. And reversing multiplication is the same as division. And then we list them all out being multiplied together. So if I wanted to factor this, the first thing that we have to talk about is something called a greatest common factor. Greatest meaning biggest, common meaning they both have it, and factor meaning the thing that like multiplies to equal it. So let's talk about what are the factors of 8x squared. Well, one of the factors of 8x squared is 2, right? Because I can do 2 times 4 and get 8, and 2 times 4x squared and get 8x squared. So that's one factor. What's another factor? I could say 4 is a factor of this for the same reason, right? I could do 4 times 2x squared and get 8x squared. Oh, excuse me. I could also say, I could say 1 is a factor of it, right? Because 1 times 8 is 8. I could also say 8 is a factor of it, right? All these numbers go into it. And then I can also say that x and I can say x squared are both like these are all different factors. I could multiply these by something and get 8x squared. So let's look at the different factors that we have for 12. So 12 doesn't have any x's, okay? But we do know that 1 goes into 12, 2 goes into 12, and this is where if you don't process these easily, if this is something that is kind of tricky for you, grab your calculator. Where's my calculator? It's supposed it's normally like that. Calculator, calculator, where'd you go? Where'd you go? Oh, it's over here. I was looking to my left, it's off to my right. Okay, so here's how you do factoring. If you're trying to find factors of a number and you're not sure, you can literally go, hey, 12 divided by 1, does it go in evenly? Yep. All right, 12 divided by 2, does it go in evenly? Yep. 12 divided by 3, does it go in evenly? Yep. Okay, so 3 is a factor. Also, the numbers that you get over here are also factors, right? So 4 and 6 are going to be factors too, but let's just keep on going. 12 divided by 4 goes in evenly. 12 divided by 5, oh, it doesn't go in evenly. So 5 is not a factor of 12. 12 divided by 6 is 2. Okay, and here's the thing. Whenever you get to the halfway point, 7 times 2, you know it's going to be the end. Because anything over 6 that would go in, we would need to multiply it by something less than 2, and the only number like that is 1. So I guess I did forget one factor. There's a factor 12. So Greatest common factor just says, hey, what combination or can I get like from both of these? Well, looks like 4 is common. So 4 is a common factor, 2 is also a common factor, and 1 is a common factor. Hey, which one of those is greatest? Oh, 4. So the greatest common factor here would be 4. So this is way, way longer than it normally takes. So let's look at another example. Let's say we've got 20x and 30x squared. So if I'm trying to find the greatest common factor, look at how I write this, the greatest common factor. Let's see, 20 and 30. So I might start out, and I know 2 goes into 20 and 2 goes into 30. Can I get anything bigger? I see they have zeros on them, so they're both multiples of 10. So does anything higher than 10 go? Oh, no, 10's the highest thing that goes into 20, because that's the halfway point. And there are things higher that go into 30. Like I know 15 goes into 30, but 15 doesn't go into 20. So it looks like our GCF here is going to be 10, but there's also letters that they share. And the way you figure out the letters is, what's the most amount of x's that goes into both of these? A single x will go into there, and a single x will go into there. So I could put an x. Do 2 x's go into here? No. So even though 2 x's do go into here, they don't go into here. So I can only say that a 10x is the GCF here. Another way that we can do this is using something called prime factorization. And this is where you take 20, you break it down. Well, I know 20 is 2 times 10, and then keep the 2 there. What's 10? Well, 10 is 2 times 5. Okay, so I have 2, 2, 5. Oh, and then there's the x, right? This is called the, oh, sorry. Can I break 2 down anymore? That's just 1 times 2. What about 2? It's just 1 times 2. What about 5? 1 times 5. And x is just x. So this is called the prime factorization. And prime factorization is just this idea that we're breaking it down into a bunch of prime numbers. And if you don't know what a prime number is just a number that doesn't have any factors besides 1 and itself. So like 20 is not prime. 20 is called a composite number. It's a composite number because it's made up of a bunch of primes. It's composed of a bunch of primes. So let's look at 30. Let's do the same thing with 30. So I know 2 goes into 30 because it's even. That's 2 times 15. Well, what's 15? 15 is 3 times 5. So that's 2 times 3 times 5. Let's see, 2 is prime, 3 is prime, and 5 is prime. So this is actually done. And then I could say times x times x. So if I'm trying to find my GCF, my greatest common factor, all I have to do is go, okay, what do they have in common? In their prime factorizations, by the way, prime factorizations are unique. You're not going to get a different one if you go all the way down to prime numbers. We'll do one more of those after this. So looks like they share a 2. Do they share another 2? No. They share a 5. And they share an x. So looks like 2, 5x. So 25x. No, just kidding. 2 times 5 times x. Well, 2 times 5 is 10, and there's an x. And this is how we get a GCF using deductive reasoning, going down to the nitty-gritty. So let's do one more. Let's say 70x cubed and 28x x to the fourth. Let's say we're trying to find the, I wanted to pick big numbers so we can really focus on prime factorization. So, so 70, well, it's even, right? So I can pull a 2 out. So I can say this is 2 times 35. So bring the 2 down. 35 is 5 times 7. Oh, so we're actually done here. And then x cubed is x, right? So let's look at 28 now. 28 is, I know it's divisible by 7. That's where my brain went first. 7 times 4. And then, oh, 7 actually doesn't break down anymore, but 4 does. 4 I can write as 2 times 2. Sometimes people put little arrows. They call these factor trees. Oh, and I have prime, so nothing more to do, but x. So if I'm trying to find my prime factor, or sorry, my GCF, well, looks like they share a 2. They only share 1 2, though. They share a 5? No. Do they share a 7? Yes. So I could say GCF is 2 times 7. And then 1 shared, 2 shared, 3 shared. 2 times 7 times x times x times x, also known as 2 times 7 is 14. X is x cubed. There's more than one way to do this. This is one way to do it. So things to note, things that make this a little bit easier are looking, okay, so x cubed, x to the fourth, the lower exponent is what they have in common. So, all right. Final example for this type, let's say we have negative 15 x to the fourth y squared, and then let's say we have negative 25 x to the third y to the third. So you could use factor trees and break this all down. And the other way that we do this is we look just, it's more of an intuitive looking at things. So I look at the 15, look at the 25. Oh, you know what? They're both negative, so I could even pull a negative out. I could say this is negative. I know 5 goes into both of those. Does anything bigger than 5 go into either of them? And so I'm thinking about it like that. And for me, no, I mean, 5 times 5 is 25, and this is 5 times 3. So yeah, 5. And then I look at my x's. I see x to the fourth, x to the 3. So the most we're going to get out of either of them is 3 x's. And then I see y to the 2 and y to the 3. So I see 2 y's is the most y's we can take out. And so here is our greatest common factor. So that's the way that I personally do these. But this prime factorization method where you break it all the way down will always work. It just sometimes takes a little bit of time. So cool. Hope this was helpful. In the next video, we'll talk about how to actually factor out a GCF.